I tell you. All right, so we're going to be starting a new unit. Some of you have all of the tests to still do or part of it, so let's get that taken care of this week sometime. Today I have a meeting right after this class, and then I have to drive up to the med school, and then I'll be back by noon. So between noon and 2, I'll be in my office today. Tomorrow will be a little bit more open, but those are just some things. I just need to warn you that this portion of the semester, we're over halfway done. Okay? And it's going to go quick. It's going to go quick because we're done right before Christmas break or winter break, whatever break you want to refer to it as. We used to be done 2 weeks after. It's not that we have the same material. We've adjusted things because the semester is actually a week shorter than it had been, and then next semester is a week longer. So what we're doing is we've adjusted our units, but I just need to make sure that don't let yourself, in this class or any of the other classes, get behind, because 3 weeks from now we're on Thanksgiving, and then we have come back after Thanksgiving. We have two weeks, and then we have final exams. So it'll be quick, but don't let it get in front of you. Don't be like, oh my gosh, I'm totally stumped. And it's just a warning for all your classes, just to think about. Okay. I'd like to start notes, if that's okay. In this next unit, we're going to be talking about linear equations. Those are equations that make lines. Equations that make lines are raised to the first power, things like that. So that's what we got going so far. All right, so you guys have all dealt with plotting points at some point in your life, I believe. Agreed? You have the x-axis, you have the y-axis. Some people call it the input as the x-axis. Some people call the y-axis the output. Some people call the x-axis the domain. Some people call the y-axis the range. Basically, the xy axis can be referred to as the Cartesian plane. And it's just two number lines that are put together where your starting point is 0 on each of them. And you get, a number line, starts at 0, or it has a center of 0 where you have negative units to one side and positive units to the other side. So the Cartesian plane of the xy axis is just two number lines that are put together. And those number lines, in this case, are part of the real number system. They're not, you don't have one that's real and one that's complex at this point. But that'll be something to just realize. But just realize those are two number lines that are put together, period. Okay? So if you wanted to go and start plotting points, whoa. Get out of that. Try to erase that. There we go. So 3 comma negative 2. Well, you have to realize, and if you can't see this appropriately, there's a grid on here. So 3, I'd go to the right 3, and then I would go down 2, and we're going to label that point A. And this is something I think you were probably introduced to graphing at probably 3rd or 4th grade, not really knowing why or when it's doing. It's just basically a way of mapping a two-dimensional thing. The XY axis can have the XYZ axis. You can also have the WXYZ axis, things like that, so you can go to different dimensions. Point B, what should I do? It's 6 comma 3. So, Casey, what do you think I should do? 6 comma 3. How would I plot that?
Go right. 6 times and then go up 3.
Perfect. So he said, so we're starting from the origin. We're going to go right 6, 2, 3, 4, 5, and 6, and then go up 3. And that's going to be point B. And notice I'm labeling them right now. A point is infinitely small. It represents a location someplace on the map. Let's see. Mac, what about letter C? It's negative 5, 1. How do you think I should approach that one?
To the left 5, up 1.
Oh, there you go. So because it's negative, it says to go to the left 5 and up 1. And there's our point C. Let's see. Tristan, letter D says negative 1, negative 2. What do you think? Do what?
It's gonna be in the last remaining
Okay. So how would I get to -1, -2? Where are we going to go in order to get there, though? Good. 1 left and 2 down. So from the origin, I'm going to go 1 left and then 2. And that's going to be letter D. And then, Mr. Summers, 0, 8 is going to be E. So what do you think I have to do there?
You start at the middle.
Middle, okay.
And then you go up 8.
And I just go up 8. So I'm not going right or left at all. I'm just going up 8. 2, 3, 4, 5, 6, 7, 8. And that's letter E. And then, Mr. Kruger, what do you think about letter F being -9, 0? How do you think I'd get there?
Go to the left 9 pounds.
Uh-huh.
And
That's it. Yeah, it doesn't go up or down at all. So a point can be in any one of that. And I want to say what Tristan said was talking about quadrants. Quadrant means 4, quad. So there are 4 different quadrants. So a point can land in a quadrant. It can land on one of the lines in between 2 of the coordinates or quadrants. And it can also land right in the very center at 0, 0, which is the origin, or the middle, or some terms like that. So a few things to note too is they label this way. So they label it counterclockwise, going left. And I've heard rumor of why it's done that way. I can't verify it, but when they were creating the Cartesian plane, the person who was creating it was left-handed. And if you think about it, that's maybe how a left-handed person might go about it. That's the only reason why they have stated that. And in quadrant 1, both the x and y component are positive. Quadrant 2, the x component is negative while the y component is positive. In quadrant 3, both the x and the y are both negative. And in quadrant 4, the x is positive and the y is negative. So you have positive, positive, negative, positive, negative, negative, positive, negative as far as those go. Okay? So that's just a kind of a start to it. Is there any questions about that so far? I hope it's a little bit of review. Perhaps I use some terms that you might not have heard before. Not that I'm going to have, expect you to know how to spell Cartesian or anything like that. It's just I'm trying to give you some history behind it. Feel okay so far? All right. So as we move down, we were talking about a little slope, and it's like a pitch to the line. And so as we are progressing on this, it says, what is the vertical change from point A to B? So vertical is which direction? Up and down. Okay, so they want to know, what's the vertical change from A to B? So how far up does it look like I've gone? 2 maybe? So 1, 2. Would that make sense? 1, 2. Okay, so that could be 2. What is the vertical change from B to C? So from here to here, what does that look like? 6? 6? Is that right? So I count. Let's see. Go 1, 2, 5, 6. Yeah, 6 would be all right. So then again, that's just how I'm changing in the vertical direction is all I'm doing. And then what about from point C to D? How much vertical does that look like that they had done? 1, 2, 3, 4, 5. From here to here. So 1, 2, 3, 4, 5. Maybe 6 as well. Would that be okay? So I'm just counting in the vertical direction only. And then down on the bottom it says, what is the horizontal change? So horizontal is which way? Yeah, it's the horizon. It's going right, left. Okay? So from A to B, horizontally, how many does it look like? So 1, 2, 3, 4? Maybe? Hang on. So we're coming to here, right? So I'm starting here. I'm going to go 1, 2, 3. Oh, it's 4. Yeah. That'll work. Cool. And I know where you guys are sitting. Sometimes it gets hard to look at the grid. You're like closing one eye and having a thing. And from B to C, how far does that look like it went from here to there? Let's see. So 1, 2, 3. I like that. And then from C to D, what does that look like? 6 maybe? 1, 2, 3, 4, 5, 6. I like it. Okay. So we just talked about vertical change and we talked about horizontal change. And then what I think we can do with that is find the ratio for the vertical change to the horizontal. So vertical over horizontal. So vertical here was 2, horizontal was 4. So we have change of 2 over 4. Could I reduce that? It's 1 over 2. Is it okay to leave it as 2 over 4, you think? I don't know. I mean, for some reason, teachers earlier in life had said, oh, they have to be reduced. Why? Because it says in the book. It's okay if you leave, when you're talking about lines, unreduced or reduced. It's up to you. So what would I prefer? Whatever is most comfortable for you. Okay? And then from point B to C, the vertical over the horizontal, what do you think? 6 over 3, which reduces to 2 over 1, which is the same thing as 2. Okay? And then point C to D is 6 over 6, which is equal to 1 over 1, or just 1. Okay. Huh. So they're asking over here, which region up there appears to you to be the steepest? C to
B to C.
B to C? So if you were to be on a bicycle or on skis or a snowboard, which part would be the one you'd go the fastest down? I think from C to B or B to C, or if you're riding up, you'd be probably your slowest ride. You're like, front tire's coming off the road. Okay, so the rise and the run, or the vertical over the horizontal, can change. It can be really steep. It can be a little not as steep. I think that might work. All right, so they're calling the slope, it's the vertical change over the horizontal change, which they're going to refer to as the rise over the run. Or you can also refer to it as the change in the y direction over the change in the x direction. So y2 minus y1, is that y squared, or does that mean something different? And is that x squared, or is that... What do you think? Is that y squared and x squared, or is it not squared? If it's squared, it'd be raised up above it, right? Now I'm looking at that top equation right here. So, time out. Dude, don't say it. Now I did it. I gotta bring that up again.
This is why we can't have nice things.
I tell you what, play with matches one time in your life. Alright, I gotta go pull that up. Hang on, let me pause that real quick.
Oh, well.
Alright, start again. I apologize. I didn't mean to goof things up. Alright, let's move that down a little bit. So we were talking about y2 and y1, x2, x1, and we're realizing that it's not y squared and x squared. So what do you think the 2 and the 1 mean as subscripts as far as the y and the x's go? What do you think?
Is it like, not that you multiply by itself, but you multiply by 2?
No. Any other ideas? What does the subscript of the 2 and the 1 mean on the x's and the y's? What do you think? What? There's 2 y's, so we're trying to distinguish a difference, and there's 2 x's. So if you have 2 different points, you need to say, okay, is there a way for me to represent one of the sets of the x's and one of the sets of the y's, and vice versa? So what would you think this point would be? And let's pretend it's exactly on that line. What do you think? 3 what? 3, 0. And what about this line, or this point right here? 6. Let's see. I'm going to count over. I'm going to 1, 2, 3, 4, 5, 6, and 6 comma 1. In your opinion, does that appear to be a pretty steep line? No, I mean, I wouldn't want to walk up that kind of slope all day long. But if I had a short distance, that might be all right. Does it appear to be rising or falling?
Rising.
Yeah.
Depends on which way you look at it.
Yeah. So I'm going to tell you this, that if it ends in the upper right, or like eventually it'll go to the upper right, it's a rising scenario. What about the one to the other side? It looks like it's falling. Okay, so if you're going to the lower right, eventually it's falling. If it's going to the upper right, it's rising. Okay, so now, if I wanted to find the slope of this, it's the vertical change over the horizontal change. So I could say, well, I went up 1, and I went right 1, 2, 3. Okay, I could do that. I could come over here, and I could pick one of the sets of points. I have to decipher which one do I want to label x1 and y1, and which one do I want to label x2 and y2. And it doesn't matter, so just pick one of them, x1 and y1, and then x2 and y2. And if you plug these into the equation where it's y2 minus y1, so 0 minus 1, over x2 minus x1, so 3 minus 6, that's going to give me -1 over -3, and negative over negative is positive, so that points to this. Huh. Okay? So negative over negative, again, is positive. We go from there. What about this next one? So we already said it's falling. It's going definitely a different direction. What point does this look like? -1, comma 2. You okay with that? What does that other point look like? 4 and -1. I like that. And again, I have to pick one of those points and label x1, y1, and pick the other point and label x2, y2. And it doesn't matter which one you pick to be first. Okay? So I picked the top one here to be x1, y1, and then the bottom one to be x2, y2. But here I could say, well, let's pick the bottom. And again, we're going to plug into the equation y2 minus y1. So I have 2 minus 1. 2 minus -1. I get up there. That's not equal. That one's negative. And then what? What do you think? -1 what? -1 minus 4. So what does this negative do? That makes it positive, so 2 plus 1 is 3. And then on bottom, I'm going to get -1 minus 4, which is -5. So what does the slope of this line appear to be versus the slope of this line? So one of them's rising, one of them's falling. What do you notice about the rising as far as the sign? It's not negative, it's positive. So a rising slope is a positive slope. And a falling slope is negative. Okay, so slope is the rise over the run. Okay, it's the change in the vertical direction over the change in the horizontal direction. It's the y components being subtracted over the x components being subtracted. So there's a bunch of different ways you could look at the slope itself. Does this all seem like you've seen this before at least once? Okay. All right. So, let's find the slope. Find the slope of a line through the point, which is A, we're going to call -2 and 1, and B, which is 5 and 7, and then graph the line. Now, how many points do you think you need to define a straight line? 2. If I have this point here and this point here, there's exactly one straight line that will go through those 2 points. If I have a point here and a point here, exactly one line. and here and here. So you need 2 points to define a straight line. They have to be different points. You can't have the same point. Now, what line does 1, 1 and 1, 1 do? An infinite amount. It's the same point. They have to be 2 different points. So negative 2, 1. So I'm going to go negative 2 and up 1. That's my point A. And then 5, 7. So 1, 2, 3, 4, 5. 1, 2, 3. That's my point B. Connect the dots and then just keep going right through it. Okay, so the slope, does it appear to be rising or falling? Appears to be rising because it's going to the upper right. And then the slope. So if I label this x1 and y1, and I label this x2 and y2, and the slope equation I think was y, come on, let's work out y2 minus y1 over, okay, so if I plug those in, y2 minus y1, I get 7 minus 1 over, what do you think, 5 minus negative 2. So 7 minus 1 is how much? 6. 5 minus 2 is 5 plus 2, which is 7. So I get 6 over 7 slope. So it's rising, so the sign should be positive. Okay. What about this next one? It says the slope of CD. So if I was going to plot point C, I have negative 4, 3. So negative 4, 3 is negative 4, 3. That's point C. And then point D is 2, negative 5. So I'm going to go over 2, down 5. If I connect the points and just keep going both directions, does this one appear to be rising or falling? Falling. What's a judgment you might say on this? Is it going to be a positive or a negative slope? I think it might be negative. Well, let's double check. Okay, so I'm going to call this x1, y1, and call this x2, y2. And then I'm going to plug it to my equation, which I have labeled right here. So I have y2, which is negative 5, minus 3 over 2 minus negative 4. What's negative 5 minus 3? Negative 8. Okay. And then 2 minus 4 is positive 6. Can I reduce that? Negative 4 over what? 3. Negative 4 over 3. So we have a slope that's falling. It's a negative slope. That's probably happening on accident. What do you think? Seem okay? Yeah. So linear equations are straight lines. Linear equations have slopes. Slopes can be positive and negative. It's positive, it's rising, that's going to the upper right. It's negative, it's falling, it's going to the lower right. Wait a minute. Horizontal and vertical lines. Hang on, so we can do this. So let's pick 2 points. I'm going to pick this point right here. And I'll pick like this point right here. So this is the point 1, 2, negative 4, negative 4, comma 5. And this point is 1, 2, 3, 4, 5, 8, 8, comma, and then up 5. So it's a horizontal line. What do you notice is the same up there? Which parts? They both have 5, and the 5 is falling in what part? The y. Okay, so again, the slope equation is this. And I'm going to label these, and I just picked those 2 points. I have x1 and y1. I have x2 and y2. And let's plug those in. So I'm going to get 5 minus 5 over 8 minus negative 4. So 5 minus 5 is 0 over 12. What's 0 over 12? Okay. So horizontal line, the y components are the same. The y components are on top. You get on top being 0. I think you might wind up with a slope of being 0. What do you think this one? So let's pick this point here. Oh, I don't know, maybe this point here. So I have negative 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. Negative 6 and 6. And then this one will be negative 6 and negative 1. So that's a vertical line. Which components seem to be the same up there?
6.
The x component. So again, we label them x1, y1, x2, and y2. We plug them in. I'm going to get negative 6 minus negative 6 over negative 1 minus 6. And that's going to give me positive. So negative 6 plus, wait, time out. What did I just do? I flip-flopped it. I'll tell you what, darn Mondays. Go back on break. All right, dude, we're out of here. I can't believe I just did that. All right, the y components. Negative 1 minus 6. And then on bottom, negative 6 minus negative 6. That's a 6. Trying to be. So on top, looks like I'm going to get negative 7. And on bottom, I'm going to get what? Well, that's positive now. Negative 6 plus 6 is. So I get 0 on bottom. Now I'll tell you, if you go on your calculator and you wanted to type in like negative 7 divided by 0, it's going to give you an error. Or it's going to say something about domain or something like that. Okay? This is actually undefined. Okay? So your slope of a vertical line is undefined. The slope of a vertical line has repeating x parts. So horizontal is 0, repeating y parts. Vertical, undefined, with repeating x parts. So horizontal line slope 0, vertical line slope 0 with a slash through it, which means empty set, which means undefined, doesn't exist. And then the last thing we're going to talk about today, let's see, pretty close, yeah, oh yeah, giddy up, all right. The last thing is, we're going to be talking about this equation where we have y all by itself. So you have y equals mx plus b. And this is called slope-intercept form. The b represents where it crosses the y-axis, and that m represents the slope. And the slope is like a map to find a different point. So m is slope, and b is the y-intercept, which is actually a point 0, b. Okay? So the slope of this first one is equal to 3. What's the slope of the second one? 2 thirds. What's the slope of the third one? Negative 2. Ooh, if it's negative, it's... No? Is it rising or falling? It's falling. It's positive. What about this one? It's not solved for y. So what do you think I should do to it? So if I haven't solved for y up there, can I solve 2x plus y equals 1? Can I solve it for y? What would I have to do on this one? There you go, subtract the 2x. So y equals negative 2x plus 1. So what's the slope of this one? Negative 2. And then this one, 3x minus 4y equals 12. I need to solve it for x. So minus 3, so I get negative 4y equals negative 3x plus 12. How do I get y by itself? Divide everything by Negative 4. So those cancel. What's the slope of this one? 3/4. What about this one? Where's the x? What number do I multiply something by to get rid of it?
It's
0. So the slope of this one, if I have y equals a number, the slope happens to be 0. Okay, 2 last examples. You still with me? You need to poke anybody in the eye? Go ahead. Need to shave anybody's eyebrows off? Go ahead. And if you have your head down, it's not nap time yet. That happened 20 minutes ago. How about now? What about now? What about now? All right. Last 2 examples. Parallel lines. Parallel lines. What do you notice about the slopes?
Increase.
They're both increasing, but could I have parallel lines that are both heading downward? Could I have parallel lines that are both vertical? Could I have parallel lines that are both horizontal? What do you know about the slope of parallel lines? What do you think?
They have the same slope.
They have the same slope. Same slope. Okay? Parallel lines do not intersect. Okay? If you have 2 lines that have the same slope, they will not intersect. Ever. Ever. Dude. All right, and then perpendicular lines, they intersect. Perpendicular means they're going to form 90 degrees. But I will tell you, if the slope of this line is A over B, then the slope of this line is going to be negative B over A. If you have 2 slopes, if you were to take the 2 slopes and multiply them together, if you multiply the 2 slopes together and the perpendicular lines, every time your answer will result in negative 1. Perpendicular slopes are opposite reciprocals. Okay? So, or negative reciprocals. Means if you have 2 perpendicular lines, one will be a positive slope, one will be a negative slope. And they're the flip over of the fractions of each other. Okay? If I have a horizontal line with a vertical line, one of the slopes is 0, the other one is undefined. So if you have a question that ever says, hey, you have one slope that's undefined, one slope that's 0, what do you know about these lines? They're perpendicular. If I say you have the slope of 3/5 of one line and negative 5/3 of the other line, they are opposite sign reciprocals. Okay? Meaning it's the flip over the fraction and the sign is opposite. If it was positive and it's negative, that means they're perpendicular lines. Okay? So, your assignment is page 78, 79 of your worksheet, which is worksheet number 1 on this unit. Okay? So I'd give you the opportunity, I'm giving you like 13 minutes to start this. Sound good? 13 minutes to start this. If you don't have a book with you, if you have a camera on your phone, take a picture of your neighbors and just write it down. And then remind me that you need a copy and I'll make you some copies, okay? Sound good? What do you got, Steve?